Today, on how it's made. Millefiori glass paperweights. Road salt. Nutcrackers. And car doors. Millefiori is Italian for 1,000 flowers. It's also an elaborate glass-making technique developed in 15th century Italy, in which pattern-colored glass rods are cut, grouped to form floral shapes, arranged into intricate patterns, then encased in clear crystal. If a picture's worth 1,000 words, these 1,000-flower paperweights speak for themselves. Two Canadian artists craft these Millefiori masterpieces, just as the renowned glassmakers of Murano, Italy did centuries ago. A mix containing silica sand, soda ash, and lime is heated to 1300 degrees Celsius, melting it into lead-free liquid crystal. With a molten crystal post, they pick up a densely colored bar of glass. They roll and shape the white color bar while stabilizing the post with cold water. Then, with the torch, they preheat an aluminum mold of a flower or other motif. Preheating the mold helps the glass flow into it more easily and assume the shape in greater detail. Once they've molded the colored glass, they return to the furnace to encase it in molten crystal. Then they repeatedly heat and shape the crystal with tools and with steam on a wad of wet newspaper until the crystal encases the flower-shaped color evenly. After reheating, they put some molten crystal on the end of another rod and grab the free end of the crystal-encased color. They wait until the glass cools to a specific consistency. Then, they begin to pull. They slowly stretch the glass into a thin and even rod, careful not to twist it, as that would distort the flower shape of the colored glass inside. This produces what's called a Murini cane, a clear crystal rod with a colored flower-shaped center. Once the Murini solidifies, they nip it into manageable lengths. Then they take Murini of different colors and designs, cut them into short rods, and bundle them into a pattern called a complex Murini. They preheat the complex Murini in a kiln to prevent shock-induced cracking. They now pick it up with a hot crystal post and, after removing the bundling wires, heat and work the group of glass rods into one. They now stretch this complex Murini into what's known as complex Murini cane. Once the cane stabilizes, they cut it into meter-long lengths, then cool them gradually in a kiln to relieve any stresses in the glass. Then they slice the lengths into 6 mm long pieces, the size required for the Millefiori paperweights. Now, using complex Murini pieces of different colors and patterns, they assemble the paperweight design, placing a unique, hand-constructed Murini in the center. This one is a trillium. Next, they encircle the setup with a heat-resistant graphite ring. This holds the pieces in position. After a final adjustment, the artists preheat a white, lace-patterned glass base they prepared earlier. This base will serve as a blank canvas for the colorful paperweight pattern. They push molten crystal onto the base. The ring contains it to the base's diameter. Then they reheat the base, making it smooth and free of air pockets, preheat the complex Murini setup, and stick the base onto it. Like before, the ring contains the spread. Another overall reheating softens the glass and fully fuses all the components. This fills crevices and smooths the surface. Now they return to the furnace to encase this paperweight core in molten crystal. Using standard glassmaking techniques, they work the crystal to a bulbous shape. Then on the bottom, they form a break-off point. A sharp tap on the rod cracks the glass at that point, separating it from the rod. They heat the break-off point and insert a piece of cane bearing the artist's initials. After a 12-hour controlled cooling in the kiln, they grind the base level. Then they polish away the scratches left by the grinding wheel. After a thorough inspection, these magnificent Millefiori paperweights are ready to be shipped to art glass collectors worldwide. When the road ahead is a sheet of ice, rock salt can make the problem melt away. Salt lowers the melting point of water to thaw ice and also prevents its formation. Salt was first used to de-ice highways and walkways in the 1930s, but it was only in the 1960s that its use spread. Unprocessed rock salt actually looks like the ice it will eventually be used to melt. This salt comes from huge crystalline caverns 300 meters below the Earth's surface along the Canada-US border. That's a third of a kilometer underground. These massive deposits were formed hundreds of millions of years ago when saltwater lakes dried up. The clarity of this rock salt is a sign of its purity. This mineral is 98% sodium chloride, or salt. They extract it in chunks from the rock face by using explosives and drilling. Then a loader scoops up the broken pieces of salt. This is called a low-profile loader. It has a shorter height to fit into tight spaces underground. It transfers the salt to the primary crusher. This crusher is a spiked cylinder that spins to break the salt into pieces small enough to be moved on a conveyor. The conveyor takes the salt to a production elevator known as a skip. It takes just a minute and a half for the skip to lift its heavy load above ground and up a tower. When it stops, the bottom opens to empty the salty cargo. The salt funnels into two chutes and lands on vibrating screens. These screens are essentially big automated salt shakers. As they pulsate, they shake out the smaller bits, while larger chunks move on to be crushed again. Then it's on to more shaking sifters. These screen out the very fine particles, and what's left will be used as de-icing salt. There are several sifters in this room. They also sift out particles that are about 10 millimeters in size to be used as water softening product. And for this purpose, the darker bits are seen as undesirable. So they remove those with something called an optical sorter. The optical sorter bounces light off the salt particles, and a computer reads the reflection to determine if they're light or dark. Jets of compressed air then target the dark bits and blast them downward while the white particles continue forward. A closer look confirms that the optical sorter has done its job effectively. The salt meant for water softening is pure white, while a few darker speckles is acceptable for road salt. Outside in the holding area, the salt accumulates in piles that look like huge snowdrifts. If the winter is harsh, road crews will use it as fast as it piles up. When it comes to bulk purchasing, orders don't come much bigger than this. Highway maintenance departments buy de-icing salt by the truckload and create their own stockpiles to be prepared for stormy weather. But individual consumers, of course, buy de-icing salt by the bag. In the packaging department, automated trays relay plastic bags to grippers overhead, and the system moves them forward. Suctioning robot arms pry each bag open. A puff of air further inflates the bag, while a nozzle pipes measured amounts of the de-icing salt into the bag. Once the bag is full, the system moves it forward again, and not a grain of salt is spilled. Finally, a heat sealer melts the plastic to close the package. It's taken about an hour for this rock salt to be mined, crushed, sifted, and packaged. And now they're ready to take it to the street. The first nutcrackers were plain, purely functional devices. By the 15th century, European woodcarvers began crafting beautiful nutcrackers shaped like animals and people. German artisans became known for their majestic nutcracker kings and soldiers, just like the one in Tchaikovsky's famous ballet. This German company has been crafting character nutcrackers since 1928. Like porcelain figurines, these nutcrackers sell as limited edition collectibles. At hundreds of dollars each, people don't actually use them for the intended purpose. But they can and do perform the job. You simply manipulate a lever to open and then close the mouth to crack the nutshell. On the factory floor, they use a multi-blade circular saw to cut all the body parts out of linden wood. Linden is ideal because it's lightweight, easy to carve, and its color is pale enough to mimic skin. These blocks are on their way to becoming nutcracker torsos. First, they go through a planer. It trims the four sides of each block, forming an octagonal shape. From square to octagonal, and next to round. But first, workers use a circular saw to cut the blocks into torso-length pieces. A conveyor feeds the pieces one by one into an automatic multi-station lathe. The first station rounds out the octagon, then forms the basic torso shape. The second station finalizes the shape. Then the next four stations sand the wood smooth so that the wood stain they'll apply later on will penetrate well and evenly. Then the torsos go three at a time into a vertical router. It cuts a notch in each one for the lever that opens and closes the Nutcracker's mouth. Next stop is a drilling machine, which simultaneously drills all the holes required to attach the body parts as well as the lever's axle. Now they dress the torso in a coat, which they create simply by staining the wood a dark color. Once the stain dries, they spray on 2 coats of semi-gloss lacquer. Every Nutcracker stands on a wooden base, under which they burn the company's logo. It's a mark of authenticity for collectors. The automatic lathe also shapes the other body parts, including the head. Workers attach a nose, then, using a router, cut holes for the eyes. Then they lightly spray on a touch of red paint to simulate a sun-kissed nose and rosy cheeks. Then, with a steady hand, they paint the whites of the eyes and the eyebrows. Once the paint dries, they apply some glue to the center of each eye, then affix an iris and pupil made of enameled tin. Now they align the head with the torso and screw the parts together. After decorating the coat with buttons and a buckle, they glue a strip of rabbit fur hair to the head, a rabbit fur beard to camouflage the notch for the lever. Then they mount the torso onto the legs, which wear painted-on boots, and stand on the base. Then this Nutcracker percussionist gets his drum, along with arms and drumsticks. They top him off with a hat made of spray-painted wood. Most of the Nutcracker's parts join together with wooden dowels. A large dowel running across the notch in the torso is the axle on which the lever rotates. This extensive cast of Nutcracker characters comes in various sizes, and you can even special order a life-sized version. Car doors have come a long way over the last century. They're lighter for improved fuel efficiency and stronger to better withstand the force of an impact. They also now contain a lot of electronic gadgetry like speakers and power windows, all of which enhances the daily commute. A car door is one of the first things many people reach for as they start their day, so let's unlock the mystery of how it's made. It all starts with carbon steel, an alloy that's strong yet malleable. Machinery uncoils and straightens it. A large blade slices it to the desired length, producing sheets called blanks. Then it's over to a powerful press. This particular one is a trial press, which offers a better view of the process than the one on the production line. The press forces the blank into a die, giving it the basic shape of 2 car doors. It's a design that's been engineered for both aerodynamics and strength. Back on the production line, the main press is churning out car doors. An automated device with fingers then grips the newly shaped steel and transfers it to a punch cutter. It separates the 2 doors and trims the excess metal from the edges. With the outer door panels now complete, a handler inspects them for bumps, dents, or scratches. He approves only those that are absolutely flawless. The next worker arranges the window frame, a reinforcing plate for the hinge and the inner door panel, all in a special clamping fixture. Its fingers grip the parts to hold them in position as the fixture rotates and 2 robots move in to weld them together. At the next station, the worker arranges steel bars and tubes on a robotic platform. They add strength to the door, so it will better withstand any impact. He places the inner door panel over the bars and tubes. The robotic platform angles the parts for welding. Another robot applies adhesive to the rim of the outer door panel. More robots dab adhesive at strategic locations. Those dabs match up to the tubes and bars on the inner panel as they made it to the outer one. A special press then folds the lip of the outer panel over the inner one. This hemming gives the assembled car door a neater edge. With the inner and outer panels now joined, the car door undergoes rust-proofing, paint, and other protective treatments. Now, over on the assembly line, a worker fits the handle into its niche and bolts it to the door from the other side. Chrome trim is clipped into place. Moving down the line, a worker installs a small fixed window in the groove of the frame. He uses a plastic protector to prevent scratches as he slides the larger window into its slot in the door and links it to a powerlifting mechanism inside. He separates the two windows with a metal divider. At the next station, this car door gets an automated side view mirror. They're now ready for the inner panel and its workings. The employee wires the panel to the door and snaps it into place. He tests the power windows, and they close to a tight seal, indicating a successful installation. A special elevator now lowers the completed car doors 6 meters to the next station. A worker unloads each door with the help of a pneumatic arm. This device shoulders the weight of the part and correctly positions the door for installation. He drives bolts into hinges to attach the door to the car. On the door side, the heavy-duty reinforcement plate surrounds the hinges and supports them. The whole weight of the door will hang on this plate as it swings open and shut. With all the panels installed, it's time for the final adjustments. They call this finessing. They examine each panel to confirm that it's flush to the rest of the car body, and they tweak the installation job where needed. Finally, they're satisfied the assembly is airtight, so it's time to close the door on this production.